This lesson on angle measures and polygons. We start by looking at a few different polygons, the triangle, the quadrilateral, the pentagon, and the hexagon, and seeing the number of sides and the number of triangles that you could create in each of those figures. So in a quadrilateral, by drawing one diagonal, I break it into two triangles. I can only draw two diagonals in a pentagon, but that splits it into three triangles. And since we know the measure of each triangle, the sum of the angles is 180 degrees, we can use that to actually get the sum of all the angles in our particular polygon. So for example, a pentagon, since it can fit three triangles inside of it, 3 times 180 is 540 degrees, and 540 degrees is the sum of all the angles in a pentagon. So we actually have a theorem that represents this, and it's based on that very last polygon there, the n-gon. And you can see that it's the number of sides minus 2 is the number of triangles that we can get, and multiplying that by 180 gives us the sum of all the interior angles in an n-gon. So here is that theorem. It's theorem 11.1, polygon angle sum theorem. So you'll want to write that down, and then you can pause the screen if you need to, and then move on to the next slide. Okay, so what we want to do is use that idea, the n minus 2 times 180, very important formula for us, the sum of interior angles, to find the sum of the interior angle measures for a convex heptagon. So we're going to use our formula, n minus 2 times 180. We have to understand what a heptagon is, so it's a 7-sided figure. So I'm going to replace n in the formula with 7, because that's the number of sides in this figure. So I have 7 minus 2 times 180. 7 minus 2 is 5, and 5 times 180 is 900. So the sum of all the angles in a convex heptagon will be 900 degrees. Let's do the same thing for a 15-gon. So same rule applies. I'm still trying to find the sum of the interior angles, so I'm going to use n minus 2 times 180. This time I'm replacing n with, again, the number of sides, in this case 15. So 15 minus 2 times 180. You're going to have 13 times 180. You can either do that mentally or you can do it on a calculator. Either way, you're going to get 2,340 degrees for the sum of all the angles in a 15-gon. All the interior angles. All right. Little different question here, so I want to highlight just a couple of points. The first is that you're trying to find the measure of each interior angle for a regular 16-gon. So in order to do that, I need to first know what all the angles in a regular 16-gon actually sum up to. So I want to start there by finding the sum. So I'm still going to use my n minus 2 times 180 formula. Plugging in the 16 for n gives me that the sum of the angles, the interior angles for my 16-gon is 2,520. Now here's the trick. I want to find the measure of just one of those angles. Since this is a regular 16-gon, any regular polygon, all the angles are congruent. So each angle measures exactly the same. So all I need to know is if the sum of them is 2,520 and there's 16 of them, to get one I'll just divide 2,520 by 16. So I'm going to get that the measure of one interior angle is 157.5 degrees. Now again, this is only true because what I have is a regular polygon. So that tells me that all of those angles were congruent. If this was not a regular polygon, I could not use this rule because the angles could all be different. But since they are the same, I can divide my sum of all my interior angles by the number of angles, which is the same as the number of sides. All right, we want to do the same thing for a decagon. Again, I'm trying to find one angle in a regular decagon, one interior angle. In order to do this, I need to first find the sum of all the angles in a regular decagon. So I'm going to use my n minus 2 times 180 formula, plugging in for a decagon 10 sides, so n is 10. So I'm going to get a total of 1,440 degrees. Now what I want to do is find one of those angles. So since there are 10 congruent angles inside this figure that sums to 1,440, I'll just divide that number by 10 to get what one of those measures. And so I have 144 degrees when I divide that by 10. So one interior angle in this regular decagon, again that's the key to this, that it's a regular decagon, is 144 degrees. Okay, so using this idea, we can actually solve for the angles in this and solve for the variable c. What we have is a pentagon. So we know that the pentagon, we'll use our n minus 2 times 180. 5 minus 2, or 3, times 180 is going to tell me that all of those are going to have to sum to 540 degrees. So I can set up an algebra equation to solve for the variable. So I have my 540 degrees, and all 5 of those angles, 18C, 32C, etc., have to add up to that 540. So there we go. Combine our like terms. We get that 135C is equal to 540. And so then we'll divide by 135. And that gets us that C is 4. Now, in this problem, we want to find the measure of each angle. So we have 5 angles to find, but what we should notice is that 2 of the angles, C and D, are the same, and another 2 set of angles, B and E, are the same. So I'm really just plugging in for 3, and I have 2 of them that'll be congruent. So I'm going to use, for measure of angle A, 35 times 4, for B and E, 18 times 4, and for C and D, 32 times 4. So for A, I get 140 degrees, for B and E, I'm going to get 72 degrees, and for C and D, I'm going to get 128 degrees. Again, just plugging in the 4 that we found for C in the problems. Alright, what you should notice about these two polygons is that now we're not dealing with interior angles, but we're dealing with exterior angles. But if I sum the exterior angles in the polygon on the left, the triangle, I end up with 360 degrees. And then when I move to the pentagon on the right and I sum its exterior angles, I still end up with 360 degrees. And what's going to be true about this is I could have a dodecagon, I could have a 12-sided figure, I could have a 45gon. It doesn't matter. When I add up all the exterior angles together for that figure, it's always going to sum to 360 degrees. So the exterior angle is a real easy one to remember. You just know they have to all add up to 360. So it's just like a circle, because the exterior angles are circling the figure. So theorem 11.2 is our polygon exterior angle sum theorem, and it tells us just that the exterior angles, where you're using just one angle at each vertex, is going to be 360 degrees when summed together. So I want to find the measure of one of those in a 20gon. I'm not having to find the sum in this case, because the sum is the same regardless of the number of sides. It's 360 every time. So here I need to find a single angle. Well, if this is going to be a regular 20gon, then every interior angle is going to be the same, so every exterior angle is going to be the same. So I can simply take the sum, 360, and divide it by 20. So I'm going to get that each exterior angle is 18 degrees. Very simple calculation to do for the exterior angles. So it's 360 divided by the number of sides, as long as it's a regular polygon. So here I have a regular dodecagon. Dodecagons have 12 sides. I want to know the measure of one exterior angle. So I'll take my 360, divide it by my number of sides, 12. 360 divided by 12 tells me that every exterior angle in that regular dodecagon is 30 degrees. So here I want to solve for the value of B. I have a lot of exterior angles in this shape. It's a hexagon, so there's 6 sides, and I'm going to add all 6 of those angles together. And it doesn't matter that it's a hexagon, it could have been a pentagon, could have been a quadrilateral, a dodecagon, whatever, but all those exterior angles are still going to add up to 360 degrees. So I'm going to set all 6 of those terms with B in it, the exterior angles, summed and equals to 360 degrees. Combining my like terms, all my B terms, and I have 120b equals 360, so dividing by 120, and b is obviously 3. So that allowed me to solve for that value, and if I had to go further in this problem and find the measure of each exterior angle, I could. One key thing to note here, let's say that I find the measure of this angle here at H, which is 33b. So I know that that's 99 degrees when I plug that in, and I could use that to help me find an interior angle. So if I wanted to find the measure of this angle JHG, I could now plug in what I got for my exterior angle, the 99, and I know that these two angles, the 99 and the GHG, form a linear pair. So I can subtract the 99 from 180. So it's going to leave me 81 degrees for this interior angle. So I can use my exterior angle to help me find one of my interior angles. Same idea here. We have a quadrilateral this time, so there's only four exterior angles to deal with, but they still sum to 360. So I'm going to add those R terms and set it equal to 360. Combining my like terms gets me 24R equals 360, and dividing 24 into 360 yields 15. So I know that R is 15, and I could then plug in for each one of those values and get the actual angle. Last question here. It says Anne is making paper stars for party decorations, and we want to know the measure of angle 1. The thing to note in this problem is that what you have in the star in the center is a regular pentagon. You can tell it's regular from the red tick marks on each side. So I have a regular pentagon, which means all of these interior angles are the same, and therefore all of their exterior angles are the same. Well, it has 5 exterior angles if I go in this direction. Let me draw these so you see what we're talking about. So angle 1 is going to be my first one. Now I'm going to go counterclockwise around this pentagon. So angle 1 was my first one, so my next exterior angle would be this one, and then I would come up here. This would be an exterior angle, this would be an exterior angle, and finally this would be an exterior angle. So those are the angles that I'm talking about that are all going to be congruent. Now there's a different set of exterior angles if I had gone clockwise around the picture, but I started with this one at angle 1, and so that's why I chose to go counterclockwise. So angle 1, just like these other angles, are going to be 360 divided by the number of exterior angles, which in this case is 5. So I'll divide my 360 by 5, and I get that angle 1 has to measure 72 degrees. So even though I had all those other triangles outside the pentagon creating the star shape, all I had to focus on was that angle 1 represented the exterior angle of a regular pentagon. And so I just need to divide 360 by 5. Thanks for following along with us, and have a great day.